So overall, the best way to treat contamination is prevention. So obviously try to avoid any contaminants that may actually cause the groundwater supply to be threatened. But again, this relationship between the amount of time that the water is beneath the ground is very key. So make sure that you understand that. Okay. The graph here that is in the bottom left of the slide is probably a little bit hard to see within this video, but if you go ahead and open up the slides that are available to you, you can see a lot more detail within it. In there you can see the different aquifers in the US and how contaminated they are. So the contamination that they have is split between geological sources or human sources. As you can see, most of the contaminants are from geologic sources for the most part, which are a little bit less harmful, but sometimes not, depending on what they are. And then the remaining parts are from human sources, so fully caused by us. If you look at the Snake River Plain aquifers, which are up here, both of them, one from the eastern Snake River Plain, the other one kind of from the western for the most part, but one of them is from Basin Fill, the western one, and then the other one is from basalt for the most part. Both of those are thankfully not very contaminated, and most of the contamination that you see within them are from geologic sources. But other aquifers like the Columbia Plateau Aquifer, which is where Pullman, Washington kind of lies overall, as you can see, is pretty heavily contaminated, especially by human contamination. Lastly, let's go ahead and look at some of the landforms that are caused by the work of groundwater. So as you know, groundwater is a great erosional feature. It dissolves rocks as it flows. Soluble rocks, especially limestone, underlie millions of square kilometers of the Earth's surface. So it's much of the crust that is made up of this limestone rock. And it is in these rocks that groundwater will carry some of the ions that the rock will react with and dissolve. So as we saw in chapter 6, limestone will dissolve easily in water that contains even a small amount of carbonic acid. And most of the groundwater that flows will actually contain some of that carbonic acid with it. So when the calcite that makes up the limestone reacts with the bicarbonate and the hydrogen ion that result from the CO2 mixing with the water, so again, that bicarbonate and the hydrogen ion make up the carbonic acid and then react with the calcite to dissolve it. So make it be fully dissolved ions within solution, no longer making up the rock, but rather just simple ions within the solution, within the groundwater that is flowing through. And by the dissolution of the rock itself, a lot of wonderful underground structures, like the ones that you're seeing in the pictures, are made. So the most spectacular results of groundwater's erosional handiwork are limestone caverns, like the ones you're seeing. Only in the US, there are about 17,000 caves that have been found, and every year we find more of them. Mammoth Cave in Kentucky is one of them, and is the largest and most extensive one in the whole world, with more than 540 kilometers of interconnected passages. And then, for example, the Carlsbad Cavern in New Mexico is another very good example. In this case, there's not as many passages, but the spaces that are in this cavern are very, very large spaces. The picture on the left that you have here is in Lewis and Clark Caverns, which are in Montana, close to Bozeman, which is where I did my undergraduate degree. Very cool place if you're ever around the area. So most caverns are created at or just below the water table in zones of saturation, or they should be made in the zone of saturation because you need groundwater to flow through in order to dissolve the rock. So it is in this zone that the acidic groundwater will flow at lines of weakness within the rock. So these lines of weakness are things such as joints or bedding planes. And as it flows through, it starts dissolving. As the dissolving process continues, it will slowly create cavities and gradually will enlarge these cavities in order for them to become the caverns that they are, that we see. So the material that is dissolved is eventually discharged into the streams or the oceans, depending on where the groundwater feeds. So once the rock has been dissolved and these large cavities are formed, the groundwater level or the water table needs to drop enough in order for the saturated zone to lay below where those cavities were. That way is how we find caverns to be empty air spaces. So it is some of the features that are formed in caverns that are the stone formations that we are seeing over here. So these are depositional features, that ones what we're seeing here, rather than erosional features, meaning that they are created by a seemingly endless kind of dripping of water that happens over great spans of time, rather than the carving of the rest of the cavern. So for example, the stuff behind here that not the little peaks, but the stuff behind is basically the cavern that was dissolved, that was carved by the groundwater flow. And then all the features that are laying from the ceiling and from the ground upward are all of the depositional landforms caused by the endless dripping of water through time. Okay? So the formations within the caverns that are formed by the dripstone are found through the study of caverns. This study is called speleology, and the features within the caverns are called speleothems, excuse me. So there are a few different kinds of speleothems. There are stalactites, like you're seeing up here. Stalactites are formations that kind of resemble icicles, and so they are formations that come from the ceiling downwards, and they are relatively narrow and kind of pointy. There are also stalagmites, which are formations similar to stalactites, but they are coming from the ground upwards. They look alike the roots found in the wetlands areas in the southwest, if you've ever been. And they tend to be a little bit more massive, meaning a little bit wider at the bottom, and they don't stack up as fast as the stalactites grow down. They're a little bit more massive because the water is dripping from the ceiling down to the floor and kind of making a larger splash. Sometimes if stalagmites and stalactites grow high or low enough, I guess, they meet in order to form columns, like the one that you're seeing over here. So in theory, every stalactite is going to have a stalagmite here at the bottom to kind of match it. And if they're let grow indefinitely, they're going to create columns like this one. Many of the areas in the world that have landscapes shaped largely by the dissolution of the limestone are going to be called karst topography. So these areas have this karst topography. Karst topography is a name given to them after a region in Slovenia, which I think it was called Krst, and so that's why it's called that way. Karst areas occur typically in humid regions and regions where the bedrock is made up from limestone. So karst areas also have many times an irregular terrain that occurs with this punctuated depressions, which we are called sinkholes or sinks, like you're seeing here in the picture or in the image. Sinkholes commonly form in two different ways. Some develop gradually over many years. So in this case, there's not a whole lot of physical disturbance to the bedrock underneath. Typically, what happens is that rainwater will flow through the rock and it will slowly dissolve the rock as it is flowing inside joints and fractures. In this case, the sinks here continue to subside little bits at a time as the dissolution continues. And the sinkholes in this scenario tend to be relatively low gradient and not a true form of concern. A second way in which sinkhole formation happens tends to be a lot faster and pretty abrupt. This occurs when, for example, the roof of a cavern fully collapses from the overlying weight. So this is what happens in this kind of cases. A cavern is formed, and because of the overlying weight, it collapses, forming a sinkhole. It is in these cases where you should buy insurance, for example. So areas that are more susceptible to karst topography tend to require you to buy sinkhole insurance, basically, if you're going to build there. So karst topography is pretty common in states like Kentucky, Tennessee, Indiana, and Florida here in the US. These are all pretty humid states, and so they have a lot, and they also have limestone, which are both combinations for karst topography to form. They also happen in countries like Slovenia, again, after which the topography is called. They also happen a lot in Thailand and in Vietnam, where you have these amazing formations of tower karsts. They happen in Mexico, where you have all the caverns in which people go dive. They happen in Colombia, actually. I have a few pictures, but I didn't add them to this lecture, of some of the caves I've been to back home. They happen in Puerto Rico. They happen in China, as you're seeing over here, and I'll explain that in a second. And basically, they happen in many, many countries. They're especially, again, susceptible in places that are humid, in places that are warm, places that are tropical. And then again, have limestone rock. So some areas that undergo this karst development look very, very different from the sinkhole topography that is explained over in the image. These areas, like the one that you're seeing on the left, are areas that are called tower karst. So this is particularly in southern China. In these cases, the groundwater has basically dissolved such large volumes of the limestone that only these towers remain. There's the only thing that are left. And these towers, for the most part, also tend to be perforated by a bunch of caverns within them and a bunch of fractures and weakness points in between them. So this is, again, a lot more common to occur in wet and warm environments. So tower karsts are typically present in tropical places. As far as I know, tower karsts are abundant here in China, and then in Thailand and in Vietnam you find them as well. Okay, so with that, we finished chapter 14 on groundwater. As always, please let me know if you have any questions, and I hope that you enjoyed this lecture as much as I did.